So hello, good day. My name is Nico Fortes, and I'll be presenting my uh, eighth laboratory experiment, which is the Fourier transform. And for the objectives of this laboratory experiment, first we will be determining the Fourier transform of signals and plot its frequency spectrum. And second, we will be acquiring data from the microphone that we will be recording later on and analyze its frequency content. So let us first start with the first part of the laboratory activity, which is the spectra with varying FFT points. So I have already tested it earlier on as shown on my command window, but I'll be displaying again the results. So for the first part, this is the generated image or plots. And on this part, it is also asked that we will be setting our N1 into 30. And it is asking what is the resulting plot looks like. So I'll be changing this N1 into 30 and check what will happen. Okay. As you can see on the, or when we change the value of N equals 30, um, the image or the graph that is produced is less detailed. So on this, we conclude that when we increase the n, or yeah, the n on this, or the number of FFT rather, on this part, the higher rather the n value or the FFT value, the plot will be more detailed and more smoother or more refined. So let us move on to the second part of the laboratory experiment, which is the spectral with varying signal period. So we will be running the code that was provided to us in our module, and here is the resulting code. Now we will be changing it as, or the module asks what will happen to the plot when the period is increased to 12, 15, and 18. So I'll be changing the period of the graph or the signal to 12, 15, and 18. So I'll start first with the 12. So this will happen, or this will what happen. Yeah. And for the 15, no, nothing. Yeah. Great. Yep. And for the 18. So in this case, as we increase the number of periods on the sine wave, um, the length of the total sample becomes, or the peaks of the spectra became sharper and taller. And also, or the peaks appears to be converging to the left, or they are converging parts to each other. And with regards to this, that will happen when we increase the period of this sine wave into 12, 15, and 18. I'll be reverting it back to the original first. And now we will be moving on to the third part, which is signals with noise. I'll be first running the program on the first part without the second and third instruction. So let us start first. What is, yep, this is the generated block for the first part of the, or the first instruction on the third part. And now we will be adding the additional instructions. This part first. This what is what will happen for the zero-centered periodogram. And for the next instruction. Okay. On to the next part, and the last part of this laboratory experiment, it is entitled the spectral analysis of speech or audio. In this part, I'll be recording an audio um, stating the alphabet letters from A to Z. I have already adjusted the code so that it will record 20 seconds, and I also utilized the audio recorder code as the wave record is not working on my end. So I'll be first start recording an audio. Okay. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. One. Okay, I'll be playing it. Okay, I'll be plotting the audio that is generated, or that was generated from my voice. So here is the time domain signal, and we will be showing the spectral analysis and its plot. Okay, so here are the, or my experiment report for the laboratory experiment number 8 for your transform. So this will be the end. Again, my name is Miko Fortes. Have a great day.